Yeah, okay, so this is the first homework that I assigned. I asked you to redo all the fractional expressions. Go and use quotient rule this time to differentiate those fractional expressions instead. Right? Okay, so just a small note. Okay, there's this thing known as early transcendentals versus late transcendentals. What's a transcendental? Transcendental just means sine function, cosine function, tangent function, e power x, and logarithm functions. So far, I haven't talked about these functions, right? Like how to differentiate them. Okay, I did talk about sine and cosine and also tangent, but not e power x and log power x. I didn't talk about it much, right? Yeah. So what you need to understand is that everything that you have learned so far, look at all these functions. What do they involve? They involve just x, right? And it just involves plus, minus, times, and divide. Correct or not? Fraction means divide. 4x is 4 times x. X squared is really just x times x. You haven't seen exponentiation. You see, so far what we have, like x squared, the base is a variable, but the power is a number. But what happens if we have 2 power x instead? Is it the same when we want to differentiate it? Can we just bring down the O power minus 1 to get the u? What will dy by dx be? Is it just x times 2 power x minus 1? Bring down the O power minus 1 to get the u. Is that correct? No, I haven't teach you yet. That answer is wrong. It's not correct. Okay, you don't know yet. You don't know yet. All right. Can I? I'll talk about it eventually, but not yet. Yeah. So just something to take note of. Later you'll see all the product rule, chain rule, quotient rule, everything will come back again, but with all these functions. Okay. Can. Good. Okay. Now quotient rule. Let me see. All these are correct, except this fellow here. Can you see the mistake? I circled the mistake already. What's wrong? Negative 10x. Okay, very good. So that is correct. It's negative 10x. This is question 8, part F, right? Let me just look at your last week's homework. Last week's homework. If I can find it first. Is it this guy? No, it's not this one. I think it's. Oh my. Is it this one? It's not set A. It should be last week. Oh. I can't remember. No, not this. Is it this? No, this is the book. This one, yes. Okay. Let's take a look at part F. Okay, you made the same mistake again. You see, 2 weeks ago you made the mistake, and last week you made the same mistake again. Must have a negative, okay? Please remember, the negative in front of the 5 is still needed. Okay, it's negative 5 times x squared. So the negative remains. One more thing. Let's take a look at this answer where you use product rule. Can you see that? Are you aware that the answers, even though they look different, they are the same? Like, let me just share this. Wrong one. Let me find the correct file. Is it set A? No. Should be. What's the name of the file again? This guy. Yeah. Okay. Okay. Can you see that? Are you aware that this guy on the right side, you see this guy? Your first answer 2 weeks ago versus your answer 1 week ago, or actually this week. Can't remember. They are actually the same. Are supposed to be the same. You use different techniques, you should get the same answer, right?
Yeah.
Yes, Okay. Let me try and convince you this time. Okay, here you see 2 fractions, but if you're using product rule. But here, if you're using on the left side, if you're using quotient rule, you should expect only 1 fraction. So what should we do to the two fractions if we want to make them look the same? We should probably add them together, right? So make what the same? Make denominator the same. So that's what we're gonna do over here.
Turns out everyone may have.
Sorry? What was that?
I don't know.
Okay, I don't know. Never mind. I'm just going to differentiate using product rule over here the correct way, and then we'll compare with the quotient rule. We should get the same answer. Okay, so let me just, I think I'll just do it on one page. Okay, so let me copy the equation first. Oh yeah, by the way, a good habit for you is to always write down y equals to 2 minus 5x squared. I mean the function first before you start to differentiate, okay?
Okay.
Like then below, directly below, you write down y by dx. Okay, very important, so that you can have a reference. And maybe if you need to refer to y again, like for example, you substitute in x and you want to find the corresponding y coordinate, you can label this as equation 1, then you can say like sub x equal to 1 into 1. So you don't have to write down the equation again. In the future, for now, the questions I give you are quite simple, so you may not find it very significant. You can just rewrite the equation. But in the future, if you're doing engineering math, the equations are gonna get very ugly very fast. So you don't want to keep on repeating the same thing over and over. Save time during exam. Make sure you learn to label the equation. Practice that good habit. Okay. Can move on. Okay, product rule. How? So this one, maybe you can rewrite it. The y equals as 2 minus 5x squared, but the denominator bring up, so 4 plus 7x cubed to the power of -1, right? Then product rule, how would you do it? Take one, differentiate the other, plus take the other, differentiate one. Okay, something like that. So here's what I will do. I will keep the first guy. I will differentiate the second guy. So bring down the old power, copy the same base, -1 to get the new. What else is missing?
21x squared.
21x squared. Because you differentiate 4, you get a 0. The plus sign remains. 7x cubed differentiate, you get 21. 7 times 3 first. 21. X 3 minus 1, which is power 2. Okay, plus, then you take the other, differentiate 1. So now you keep the other guy. Then you differentiate this guy, which is what is it?
Minus 10x.
Very good. Minus, finally. Okay, minus 10x, don't need square anymore. Okay, then we can clean up this guy. So here, power -2. Let's just rewrite it at the denominator. So this is 4 plus 7x cubed, bracket, power +2 at the denominator. These guys are all on the numerator, so I'll just bring it over. Bring it over. 21x squared plus a second fraction. This guy is power -1, you can bring it down. So it becomes a 4 plus 7x cubed to the power of +1. You don't need to write the 1. Okay, then -10x is on the numerator. How do you make the denominator? How do you add fractions again? Let's say 3
denominator the same. Square
like
the second one.
Square the second one. So what do you mean? Maybe I give a different example. If this is 2/25, how would you add these two fractions? Would you square both sides so this becomes 3 square 9, then 5 square 25? Is that correct?
I'll do this.
Correct. That's the correct way. You multiply top and bottom by the same thing. In this case, one copy of this base. So it becomes bracket 4 plus 7x cubed at the numerator. Then this one becomes square. Okay. Then you have the same denominator. Okay, this question mark is clearly not equal. You're supposed to make the denominator the same by multiplying 5 top and bottom, not square both sides. So anyways, now that the denominator has that square, you can combine together into one single denominator, add everything on the numerator. For this part, we can clean up a bit. -1 times 21, -21x squared, bracket 2 minus 5x squared. I won't expand it, I'll do it later. And here, okay, maybe I can expand already. -10x times 4, negative 40x. Negative 10x times positive 7x cubed, negative 70x power 4. This part, maybe I also expand now. Is that too fast if I expand now?
No.
No? Okay, I'm just going to drag this aside and then expand it. Negative 21x squared times 2 is negative 42x squared. Negative times negative is a positive. 21 times 5 is a 105. X squared times x squared, x power 4. Okay, good. Okay, clean up. 105 minus 70 is 35. All right, so we end up with 35x power 4. Then anything else to clean up? No more. Just rewrite it in descending powers of x because I like it that way. 4, 2, 1 powers. Denominator remains. Okay, can. Now it's very neat and tidy. We can move on to quotient. So far, what I've just done is I've used product rule, but I can also use quotient rule to get to that answer directly. So now, quotient rule. Of course, your answer here is correct, huh? It's only that the 10x should have been a negative 10x. So let me just do the correction for you and show you that they will give you the same answer. So if this is negative 10x instead, this here will be negative 40x, and this here will be a negative 70x power 4. Anything else we can do to clean up? Yes, 105x power 4 minus 70x power 4, which is really just 35x power 4, right? Yeah, then of course there's a minus 40x, there's a minus 42x squared, which is the same as these two guys on the numerator. So confirm they are the same. Can? So they are equal. Yeah. So both ways will work. Just make sure you are careful in your differentiation chain rule. Remember the negative sign. Moving on. Next. Any questions first?
No.
No? Okay. Just be careful of the negative sign. Okay, so anything else is wrong? Over here. Yeah, point slope formula used wrongly. Okay, I've shown you two different ways to do it. Okay. Have I sent you this file? I can't remember. I think I did.
Yeah, no, you send me this file.
Okay. Ken, so do you know the mistake already? What happened here?
No.
Okay, so what happened is that you found a point already, which is wait, did you find the point here? Wait, it's given. You found it's given, you're given a point 1,4, and you also found the gradient m equal to 7. So you have point, you have slope, so you want to use point slope formula, but you used it wrongly. The trick, maybe I confused you. What I was saying during the lesson, maybe I wasn't clear enough, is the following. Let's say you start off with the point slope formula, you memorize it like this: y2 minus y1 over x2 minus x1. What I'm saying is you can remove one of the index. So for example, if you remove the 2 here and 2 here, what do you end up with? It's just y minus y1 over x minus x1. This y and x are now generic x. You just leave it alone. Y is y, x is x. Don't need to sub in. What you sub in instead in this formula now is the x1 and the y1. You're given the point 1,4. So this is x1, that is y1. The 1 is a x1, the 4 is a y1. Then you just sub in accordingly. Then you end up, and also, so what you end up with is the right-hand side being y minus 4 over x minus 1. Do you understand the color coding? Blue becomes blue. I don't know what color is that. Or peach becomes peach. Okay. Then here dy by dx. Then I draw a line x equals x1 equals to 1. It's just saying substitute x with 1 into the dy by dx expression, and we realize it's a 7, the gradient. So you can just sub in the left-hand side with a 7. And this gives you the point slope formula. You just need to multiply the denominator over. Okay? Can you see?
Okay.
That's the point slope formula. Another way to do it is here. What I did was I removed the index 2 from the gradient formula. You know, since sec 1, you just remove the 2 and the 2. Here, there's another way, which is to remove the index 1 instead. Previously, remove 2. Now, I remove 1. Remove index 1 instead. Would that still work? Yes, it will still work. So take a look. y2 minus y1 again over x2 minus x1. I remove index 1, I remove index 1. So it's just a generic y, generic x. Leave it alone. You have x2, you have y2. Those will be replaced respectively with 1 and 4. I think you can see the color coding, right? Blue with blue, purple with orange with orange, whatever that color is. And then purple replaced with 7. Okay, then you end up with this guy, 7 equals to 4 minus y over 1 minus x. Take a look, compare and contrast with the previous guy. We had previous guy was y minus 4 over x minus 1. Now it's 4 minus y over 1 minus x. Can you see that they are the same?
Yeah.
It's a bit like 2 minus 7 over 3 minus 5 is equivalent to 7 minus 2 over 5 minus 3. Because you can factor out negative 1 from the top. Can you see that? Factor out the negative. So that means that negative and negative will cancel away, then you're just back to the original. So they are the same. Both ways work. Okay, that's what I was saying last week during the lesson. This is how I remember the point slope formula. I start with the gradient formula, then I chop off one of the index. Gradient formula, chop off index. Done. Yeah, but of course, if you find that confusing, just remember it the usual way, which is directly y equals to what's the gradient times x minus x1, and then you plus y1. That also works. Just memorize this format also okay. Can?
Okay.
Yeah, just get the right order. Just make sure you get the right order. Here you mixed up the order. Take a look. The correct answer is y minus 4 equals 7 times x minus 1. You wrote 7 times 1 minus x. Off by a negative sign, whole thing wrong. Okay? Then if you know how to find equation of tangent, equation of the normal is just finding negative 1 over 7. And also over here should be x minus 1. Other than that, your answer is fine. Just need to change this to x minus 1 and you are okay.
Wait,
okay.
To change to normal is what thing?
Oh, I'm saying that you're working assuming that the equation of the tangent you found here was correct. Your working over here is perfectly fine. It should instead be x minus 1. The equation is y minus 4 equals to negative 1 over m, right? Negative 1 over m. Then multiply x minus 1. Okay, that's the equation of the normal. Equation of normal. Okay, question 10 done. Any questions? No? Okay, good. Moving on. Okay, let's see. Nothing wrong. Oh, presentation. Okay, it's just a small problem, but I want you to learn the notation. Equation of the normal to the curve, then you have to find the gradient of the tangent first. So here, after you sub x equal to 2 into equation 1, you're trying to find the gradient of the tangent. You should use this notation, dy by dx, then draw a vertical line, write down x equal to 2. Okay, instead of just writing an English sentence and then start writing numbers. It doesn't flow. It's not, the English sentence doesn't make sense. You need to have a subject of the equation, of the sentence. Like who kicked the ball? Alan kicked the ball. Alan over here. Okay? Okay, Ken, moving on. Where is my set A? Over here. Okay, set A part 1 question. 1A is fine, 1B and 1C is very bad. Can you see what's wrong with 1B? What are you doing here? You took the x, you differentiate, you get 1. You took this guy, you differentiate using chain rule, okay. Then you multiply them together. You see, I only teach you to differentiate term by term, not factor by factor. Can you see that these two things are multiplied together? Multiply means they form a product, right? Yeah. So I give you more space. Correct, good. And carry on. Very good. Differentiate x, you get a 1. So don't need to write the 1. Good. Then you can factor out if you want. 1 plus 2x power 3 bracket. Then 8x plus 2x becomes 10x plus 1. Yeah. Good. Okay. Okay, you know how to do it. Just need to realize there's a multiplication going on here.
What was I thinking?
I think you are confused with x plus 1 plus 2x to the power of 4. Then you differentiate. In that case, you would be differentiating term by term. Term by term like this. Okay. Differentiate the x like this, differentiate this guy separately with a plus sign in between. But you over generalize the rule already. I only said that you can differentiate term by term when there's plus sign in between terms. Here it's a times, right? When they put x then bracket, it means there's an invisible multiply sign over there. So you cannot do if this was a time sign instead of a plus, the rule doesn't follow. You cannot use the same rule anymore. There's no such thing as differentiating factor by factor. Okay. Yeah. So this only works when it's a plus. If it changed to times, it doesn't work. Okay, part B done. Part C, let's see. Here, your up to this step is fine. Your quotient rule, very good. But then when you're doing the algebra, you factor out wrongly. You see, here is a negative half. Then you factor out square root x. Can you try again? Try again. Wait, let me give you more space. Hold on a second. Copy and paste like this. Try. Clean factor out the square root x or x power half carefully. And what was the thing I told you about factorizing out? Do you factor out the bigger power or the smaller? Yes, negative half, right?
Oh shoot.
This is positive half. That's negative half. So who is smaller?
Negative half, factor out negative half. The x to the power of half become x to the power of 1.
Correct. Yes. So let's do you want to try writing it yourself?
I don't know why my thing is not.
Responding. Okay, never mind. Then you tell me what to write.
Because the here is like a white space.
Yeah, so you can I purposely make it a white space so you can write.
Oh lol. Okay.
Yes. Please try.
Okay.
Good. All over.
Huh?
All over x. Okay. Good. Hey, you got negative power. What can you do?
Bring down.
It's a factor already, so you can bring down. Okay. Yes. 1 plus half is 3 over 2. Yes. So square root of cube. And the numerator becomes? Perfect. Good. Yes. Okay. Yeah, so please be careful with your exponents, okay? This is why I say at the beginning, you must revise your exponents. When you do differentiation, exponents is the problem that most students have. It's not the differentiation. Like, you see, quotient rule, you know how to do it perfectly. Over here, quotient rule is fine, but the rest is algebra. Okay? Okay, let me just take a screenshot of this. I will send, wait, hold on. I will send this to you on Telegram, so in case you need to copy, and then we'll move on. Yeah, okay, let's move on. Next, help me to clear the screen.
Yeah.
Okay, can you see a mistake over here with your differentiation? This one, chain rule problem. Again, whenever the constant is in front and then you got like a negative sign, then 7x power 5 and then power, I don't know, 3 over 2 like this, then you get confused. Differentiate the first term 5, you get a 0. Differentiate the negative 7x power 5, leave the negative 7 alone, times, bring down O power minus 1 to get the new bracket. Wait, that is only for the chain rule part. But anyways, that's just a random example. Can you see the mistake you made over here?
Missing.
Correct or not? If you differentiate a square root and 1 minus 2x, you need to use chain rule here.
Yeah.
So bring down the half. Okay, hold on a second. Where's my half? Oh, sorry, I was wrong. You were doing 2 steps. Oh, you're correct. So what you did was you found this as half to the power, half times this guy to the power of negative half. Then you multiply by use chain rule -2, is it? Then 2 and 2 cancel away. Oh, right. Oh, sorry, I was wrong. You're correct. I was too slow. Wow, so many steps in one line. Okay. Right. Okay. So you differentiate and you get this answer. The 2 cancel away. There's a negative sign over here, which cancels off with that negative in the middle to give you a plus sign over here. Negative and negative becomes positive in the middle. Is that what you did?
I'm not even sure.
Okay, should be. Okay, then it's correct. Good. So then square the square root to cancel away. Then this one negative half, this one positive half power. So who is smaller? Negative half is smaller. You factor out the negative half power factor instead of the positive. Always factor out the smaller power. So 1 minus 2x to the power of negative half, you factor it out. You're left with 1 minus 2x to the power of 1 because 1 plus negative half is positive half. Of course, positive 1 power means you can drop the positive 1. Then there's a factor of x plus 1 that remains after you factor that guy out. Then 1 minus 2x plus x plus 1, they will just simplify into minus x, correct? 1 plus 1, which is plus 2. But there is no x squared. So the question asks for nx squared, which means n equals to 0. Okay, your answer is correct. Sorry, I was wrong. Good. Okay, nothing to say. Moving on. You use the correct notation. Yes, keep up the good work. Very good. Yes, use this notation, okay? dy by dx, draw a line, x equal -1. See, you don't need to write anything else. Sub x equal to blah, blah, blah into blah, blah, blah. Don't need. Just draw a vertical line, x equals. Okay? It's more efficient. Right? Okay, next. Yeah, everything is correct. Okay, nothing to say. Good. Set B, let's go. So, set B, something wrong. I don't know what happened here. Can you see? -3 suddenly become +3. Why? Did I miss something?
I don't know what happened.
I also don't know what happened. Yeah, careless mistake, is it? I guess. Yeah, the -3 should remain, right?
Yeah.
Nothing should happen to it all. Okay. Yeah, so just be careful of that. Okay, let's just write it down nicely. So if it was so it is supposed to be 16 over 9 times x power -2. 8x power -1 minus 7 bracket to the power of -3, which means that you can bring the -2 power and -3 power to the bottom. What does that mean? What does this look like now? This means you'll get 16 over 9 times 1 over x power positive 2, 8x power negative 1 minus 7 power positive 3, like this. Okay, and I think this is good enough. Don't need to simplify anymore. You could, if you really wanted to, bring the 16 to the numerator, bring the 9 to the denominator, write it like this. It's the same thing. And you can rewrite this x power negative 1 as 1 over x, or 8x power negative 1 as 8 over x. I don't need that. Okay? Can? And that's it for this question. Any questions?
No.
No? Okay, just differentiation only. Then for part B, okay, here, just leave a bit of a gap here. Like, I almost misread it. When you draw the square root and power 5 here, I thought it was a power 5. Yeah, it's not, right? It's a root 5.
Yeah.
So just leave a bit of gap. Okay, leave a bit of gap. It's the power 8, then 5th root. So yeah, just leave a gap in case it's misread. Okay, no questions, right?
No.
Fine. Okay, good. Okay, for question 2, is it? For question 2, yes. Just a challenge for you, extra. Try to find the exact value of C. Your answer is correct. The decimal value.
How can find exact value?
Yes. So
I
that means, huh?
No, I thought my answer would be wrong because I was like, why is it so weird?
Yeah, your answer is correct. Your answer is correct. Just need to find, just an extra challenge is to find the exact value, meaning that here, when it's plus minus square root 16 over 7, you can maybe simplify a bit. Square root 16 over square root 7, which is 4 over root 7. Don't need to rationalize the denominator, it's fine. Then you just sub in this exact value into the x. So what will we get? Y equals to 4 times. I'm using a very lazy notation now. Plus minus 4 over root 7 plus 8 over plus minus 4 over root 7. Okay, a bit like the sine A plus minus B, that kind of notation. I'm just being lazy. Okay, then this simplifies into what? 4 times 4 is 16 plus minus 16 over root 7 plus 8 over a fraction. So essentially the square root 7 goes to the top. So it's 8 root 7 over plus minus 4. 8 and 4 cancels away. This becomes a 2 at the top, 1 at the bottom. Plus minus 1, that so this is 2 root 7 over plus minus 1, which is essentially just plus minus 2. So we get, plus minus 16 over 7 plus minus 2 root 7. Okay, which means that it's really just curly brace, positive 16 over 7 plus 2 root 7, or negative 16 over 7 minus 2 root 7. Oh, I need more space for this. Give me a second. When x equals to, in this case, positive 4 over root 7, comma, when x equals to negative 4 over root 7. Or maybe I don't say when, I say, oops, eraser size too big. Or maybe I should say if. Okay, this is how you present it. One way to present it, if you don't want to write so much. Draw a curly brace, write down the 2 possible answers, but then put a comma and say if x equals what value. Put a comma and say if x equals to some other value. Okay? That's the answer. Yeah. Then that's not enough, because that's just the y coordinate value. You still need to sub in the x, sub in the y into the 4y equal 2x plus c. Remember the equation? If you have the question paper, yeah, you still need to sub the y in, sub the x in for both cases, and then solve for c. Essentially, c equals to 4y minus 2x. So sub in and you get the corresponding c value. I'll leave that as an exercise for you. I'm not gonna do it. You can go and find the exact value. of C. Values of C. Okay, moving on. Question 3. So here, you are asking me d by dx differentiate k. I'm sorry, d by dx of k. What is it equal to? Is it? You're confused by this guy. The answer is 0. Because k here is what? K here is a. Do you have
Is
the
a
question?
what?
Do you have the question paper? The file.
Constant.
Constant, yes. K is a constant. So what happens? What is a constant? What are some examples of constants? 0, 1.234. Square root also constant, negative. 8 is also a constant, positive integer. Negative of pi over e to the power of 42. Also a constant, right? Pi is just some number, e is just a number. Divide, you just get another number. Raised to the power of 42, still another number. You times negative, still a number. What happens when you differentiate a number?
0.
0, exactly. You just get 0, right? So that means this k can be any number, whatever it is, even though we don't know what it is, as long as we know it is a constant, differentiate, and you will get a 0. Okay, so that means that your answer is just 3x squared minus 6x minus 9 as dy by dx. How to continue? What did the question ask? What did the question ask?
They ask. Oh,
B3, last page of the differentiation AMAX 360 book.pdf.
they ask find the possible values of k for which x-axis is tangent to the curve.
Yes. What does that mean?
X-axis is tangent to the curve. I think it means that dy dx is equal to 0.
Correct.
Because the gradient is 0 because it's parallel to the x-axis.
Yeah, it's a horizontal line. Right? X-axis is a horizontal line. The tangent is itself the x-axis. So here, how would the graph look? How would the graph look? The graph will look something like this. I don't know how the actual graph looks. Let's just approximate it. If this is the x-axis, can you see my y and x-axis? Can Yes. The graph will look something like go up, go down, and then touch and bend up. And bend down and touch the x-axis and go back up. I don't know. Actually, that's a bit too many curves. It's x power 3 only. Probably looks something like this. Okay. Then the x-axis is like a horizontal line that's tangent to the curve. Okay.
Okay.
Yeah. So what do you do now? Dy by dx equal to 0, right?
Yeah.
So that means
3x squared minus 6x minus 9 equals 0.
correct. Yes. Then can you solve? Hey, let's simplify this first. Cancel off our 3. So x squared minus 2x minus 3 equals 0. I can factorize manually already. X minus 3x plus 1, right?
Mm.
And then you end up with x equals to positive 3 or negative 1. X equal negative 1 or x equal to 3. Okay, are we done?
No.
No, what do we want to find?
Y coordinate.
No, we want to find k. But yeah, actually, let me think a bit. Okay, if we sub in x equals to these values, the possible values of k. What will we end up with? Ah, right. Okay. Right. Okay. If there is a tangent at which is if the tangent to the curve is the x-axis, right? It means that y coordinate is a certain value. What is the y coordinate? Let's look at this point here. What's the y coordinate? Like in this case, like we got what, a positive 3, is it? What's the y coordinate?
0. I mean,
0. Yes, 0, correct. 0, it has to be 0 because it's on the x-axis itself, right? So we have x equal to 3, y equal to 0. X equal to 3, y equal to 0. Then you can sub in. Of course, you can do the same thing with -1. My picture is not accurate, so maybe the graph looks something like, I don't know. Let me think a bit. Let me try and visualize this. Maybe there's like 2 versions of the. Okay, that doesn't really make sense. Okay, you know what? I'll just look at the visualization later on Desmos when we are done with the algebra. Okay, so since tangent is x-axis, this implies the y coordinate of point of tangency. Point of tangency is just a fancy way of saying the point where the tangent line cuts the curve, but fewer words is 0. So sub -1, 0 into y. What do we end up with? We will end up with what's the equation of y again? X cubed minus 3x squared minus 9x. So it's -1 cubed minus 3 times -1 squared minus 9 times -1 plus k equals to 0. Solving for k, what do we get? Let's see. This guy is -1. This guy is +1 with a -3. This guy is +9. -1 minus 3 is -4 plus 9. This is +5. Right. Bring over, you get -5. Okay. Good. So that's the first possible value. When k equals -5, you have -1, 0 as the tangent. Yeah. Moving on. So next, if x, the next coordinate is just 3, 0. So you sub this into y. So x equal to 3, y equal to 0. So you just do the same thing again, but this time with 3 instead of -1.
Okay.
Okay. Can understand now the y is now a 0 because we are on the x-axis. This part is 0 because we are on the x-axis, the point of tangency. Okay, so solving and we get the k value. Let me see what's this value. 3 cubed is 27. Not 9. 3 times 3 is 9. 3 squared is 9, but 3 times 9 is 27. Coincidentally. Then -9 times 3 is also a 27. Okay, a bit confusing. Let me share with you a meme. Okay, lame meme. Okay, I just saw this. On Telegram. This guy. Do you get the difference? I just sent it. Go look at it now. Got something important to learn. Can you see the photo?
No.
No? It's on Telegram.
Oh, lol. Lol. Okay, that's funny.
You get the difference or not? It's very important. It's a coincidence that 2 squared 2 plus 2 2 times 2 is the same value. That's why elements are hugging each other. But 3 plus 3, 3 times 3, and 3 cubed, they are different, okay? What's 3 plus 3?
6,
What's 3 times 3?
9.
What's 3 cubed?
Wait, 3 cube is 27.
27. Make sure you get that. Don't confuse them. Okay.
Lol, that's fine.
Yeah. Okay. Make sure you get that. Okay. Okay. Back to the question. So over here, it's a coincidence that they're all 27. Okay. Okay. Whatever. Just calculate it slowly. Use a calculator. Anyways, negative 27. Bring over.
Positive 27.
Positive 27.
Equal 27.
Yes. Good. So those are the two k values. So what does it mean? It means that let me just demonstrate on decimals. Yeah, you need to visualize how the graph looks. Even though technically for Amex you are not allowed to use a graphing calculator. I think it is useful to learn. Let me just share the screen first. Give me a second. Okay, let me look at the equation first. What is it? Y equals x cubed minus 3x squared. Okay, minus 9x plus k. Plus k, but in this case, we had two different values for k, namely negative 5 and 27. And 27. Okay, so over here, can you see that the point of tangency is negative 1, 0?
Yeah.
This is the cubic curve, power 3 curve. It goes up, it goes down, it goes up again. So, oh yeah, by the way, I want you to notice something important. Let me just change the x-axis first. Give me a second. Negative 5, positive 5 would be good, I think. Yeah, now it looks nicer. How many turning points do you see? Turning point means you go up and then you go down again. There's one here, right?
Yeah.
How many do you see?
2.
2. Why is it 2?
Because
Power
you
3.
zoom in.
Huh? Sorry?
Because you zoom in.
Because I zoom in. No, okay, yes. But I mean, more importantly, if let's say I just change the number, here negative 3, let's say I change it to negative 30. I zoom out. Can you see that there are still 2 turning points here and here? It's still 2. Why? Okay, change it back to 3. What's the main thing I'm trying to highlight here? How is it related to power 3?
How?
Okay, think about
Yeah.
it. How do you find those turning points? What are their tangents? You see my
Their
mouse?
tangents are both like
Parallel to?
x-axis.
Which means they have gradient of?
0.
So what is equal to 0? Gradient equals 0. What's the formula for gradient? What's the name of this topic?
Formula for gradient.
Gradient of a tangent.
dy dx.
Exactly. So the dy by dx equal to 0. So what happens when you dy by dx x cube? What happens to x cube when you differentiate?
3x squared.
X what? X squared, right? So that means dy by dx will be something x squared, blah, 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 equals to 0. Then if you have an x squared equal to 0, how many answers will you have for x?
You have 2.
You have 2 answers. And what will those answers be? They will be the x coordinate here and here, negative 1 and positive 3. Okay, guaranteed. That's why there's 2 turning points. When you differentiate, the power drops by 1. And if you equate it to 0, you solve for x. Since it's already dropped by 1, 3 minus 1 is 2. That's why you have 2 turning points. So what happens if I make an extension to this? What if I have x power 4 instead? Okay, let's hide the graph first. X power 4, 9 plus. How many curves do you expect? How many turning points do you expect this time? Power 3 got 2. Power 4 got how many?
3.
3. Exactly. Let's take a look. Oh, actually don't have. You see, sometimes the graph looks a bit weird. Only 1. Not a good example. Let me try and adjust the numbers. Maybe -5. Does this work? Still doesn't work. Let me see. If I want to guarantee real roots, this might be a bit difficult to design. Okay, this is not working out. Okay, something like this. You see? You see? It's like a W shape. There will be 1, 2, and 3 points. But also another thing I want you to remember is that these points are not, these curves are not symmetrical. They are not the midpoint. It's not a quadratic curve anymore. Take a look. Here is -1.228. Here is +0.536. What's the average? What's the average? Let's take out our calculator and calculate this. -1.228 plus 0.536, then you divide by 2. Divide by 2, you get -0.346. Okay? But this point here is -0.569. Is it the average directly in the middle?
No.
No, okay, good. Please remember that. Please remember that. From power 3, power 4, and power 5, any other power onwards, the graphs no longer have a symmetrical turning point. I mean, it's not symmetrical about the turning point. Only for x squared, it's a special case where then you will have what do you call symmetry about the turning point. Like for example, here is -2.5. It's directly in between those 2 points, -6.531 and +1.531. Okay. Can? Okay, very good. So that was just a rant on the graph. So let's just go back to the original question. When you have k equal -5, the tangent, the x-axis is a tangent at -1, 0. Whereas if you have this new graph instead, the blue graph, the point of tangency is at 3, 0. The point of tangency of the x-axis is at 3, 0. Can you see that? Okay, and do you understand the relationship between the red and the blue? When you change from -5 into +27, can you see a pattern?
Move up by 32.
32, yes, correct. Move up, that's the main thing. Okay, it's translated upwards by a +32 units. Okay, let me just give you a demonstration. Like for example, -5 plus a, and then I add slider a, then I can, I need to go up to 33. Maybe this step size should be 1. You can see the graph. Eventually it goes until 32, which will be the +27 now. -5 plus a, where a is a 32, will give you a 27, I think, if I didn't count wrongly. Okay, can you see the animation? Okay, you go from bottom, you go all the way up. Okay, that's how you think about these graphs. Okay, back to the question. Okay, next question still in set B. Let's go. Where will be question 4? Okay, here x is set. You ignored x. Product rule is required, but you did not use it. Let me share the screen first. Oops. It's not working. Why is it not working? Let me try again. Can you see the shared screen? Can see? Okay, x is set. Why? Yeah, my pen is not working. Give me a second. Can you see my pen?
Yeah.
Okay, good. Can. So here, why? What happened? What rule are you using over here? Chain rule on this guy. But do you realize that there's an invisible times sign over here? X times square root. So you cannot directly use chain rule. You need to use what rule first? Product rule. Okay. And differentiate x, which will give you 1. So times 1, nothing happens. Okay, good. That's how you should do it. But this is very messy. So I think we should restart this question. Okay. Let me just add a page. But yes, your first conclusion is correct. When you have y equal 2x plus 1 as the tangent line, then of course the gradient is 2. So dy by dx must equate to 2. But your dy by dx wrong, so no choice, have to redo. Okay, let me just add a new page so we have more space. Question 4. Yeah, so this is x times half times a minus 3x squared to the power of negative half, then multiply by negative 3 times 2 is 6, so 6x. Okay, square 2 minus 1 is just power 1, so x power 1, don't need to write the 1. Plus, take the other guy and differentiate x, you get 1. Okay, clean up. Now, who do you factor out?
The lower power minus half.
Correct. Okay, so a minus 3x squared to the power of minus half, square bracket. Can you continue? Tell me, I write for you.
Minus 3x squared.
Huh? Minus 3x squared? Oh, correct. Sorry. Yes, continue.
Bracket open a minus 3x squared. Plus
sign over here. Okay, good. You don't need the bracket actually. You don't need the bracket. Like because what's the difference? You see, without the bracket.
Minus a minus 6x squared.
So this becomes a minus 6x squared, and the front part is a negative power. So you can bring it down, and then this becomes positive, like this. But yes, half is the same as taking a square root. You don't need the brackets anymore. Then you're done. Good, nice. Okay, so this is dy by dx. What's the question? Let me read the question again. Or find the tangent to the curve. Okay, wait. Tangent at which point 1 comma b parallel to y equal 2x plus 1. So essentially your gradient here is 2. dy by dx equal to 2. dy by dx equals to m equals to 2. You want to find the values of a and b. Okay, can. So we have all the information we need already. So let's just label this original y. So a good habit is to label the original y before you start to differentiate. So here, when you write down y equal 2x plus 1, you may accidentally confuse yourself during exam and you differentiate 2x plus 1. Then that will be very, very bad. Okay, so it will be a good practice to include a y equals what's the equation you're trying to differentiate first before you write down dy by dx. I'll call this equation 1. dy by dx answer, I'll call this equation 2. Okay, so now I'm going to just sub. Actually, do I need to write sub? Let me see. Okay, yes, I will. I'll say sub 1 comma b into 1. Okay. You can just write down you can just write down 1 comma b like this. It's very clear. It's clear that this is the x coordinate, that's the y coordinate. Can? Don't need to say x equal to 1, y equals to b. Don't need. So here y equals to b, right? So this means that this y over here becomes a b. Equal sign here remains as equal sign. Maybe I'll just put blue color for b. Then x times whatever, I'll just replace the x with 1. So it's 1 times square root of a minus 3 times 1 square. Can? Good. Okay. Then we can simplify. So b equals to square root of a minus 3. Square both sides, b squared equals to a minus 3. I think I will just leave it alone now. If I need to, I can make a the subject, I guess. So b squared plus 3. Not sure if that's required. I'll just leave it. Then I move on to the next piece of information we have. What is it? What's the next piece of information we haven't used yet? What other information have we not used yet?
We have not used.
This part used already.
Mm-hmm.
What else is not used? Dy by dx. We found it then.
Sub x inside.
Okay. What x value would you like to sub inside? Or should you sub inside?
If sum in 1.
Exactly. The point at which you're tangent to, you sub in the x coordinate. Okay? Must remember this idea. So sub x equal to 1. Okay, maybe I'll use black color. Sub x equal to 1. Okay. X equals to 1 into where?
I thought
Into where? Okay. Yes. Oh, more efficient notation. Yes. Dy by dx. Line x equals to 1. This will give us a minus 6 times 1 square is just 6. And a minus 3 times 1 square is a minus 3 with a square root. Okay, good. So this is the gradient. But what do we know about the gradient? It's equal to?
it's to 2.
Very good. It's 2. Good. So from there, we can solve for?
A.
For A. Okay, good. So let's cross multiply this. A minus 6 equals 2 times square root a minus 3. Then maybe I can square both sides now. So bracket, bracket, square, bracket, bracket, square. Something times something square is the same as AB bracket square, which will give you A square B square, which means this should actually become, right-hand side should become?
Right-hand side should become 4 times A minus 3.
Very good. Yes. Square root becomes no more square root. Square the 2. Don't forget, it will become a 4. So, most people will forget that this becomes a 4. They'll just write down 2. Okay, how about the left-hand side? A minus 6 square. Is it A square minus 6 square?
No.
No.
It's 8 square minus 12. Wait. A square minus 12A plus 36.
Very good. Yes, please remember, a lot of students, after they reach this point in differentiation, because they are so confused by the overwhelming amount of information, they forget their basic stuff. A minus B bracket square binomial expansion. Power 2. 1 to 1. Okay, but of course, it's just a basic identity. Hopefully, you can remember. Moving on. So expand the right-hand side, you get 4A minus 4 times 3, 12. Left-hand side, let's just copy and paste it first. Then you can bring everything over to one side, equal to 0. So minus a 4A, you get A square minus 16A. Minus 12, bring over, become plus 12. So it's a plus 48. Is that okay so far? Yeah, then now you just use a calculator to calculate this. 1 minus 16 and 48. You end up with 12 and 4. But I'm just going to pretend that I know how to factorize this in my head. And then I get A equal to 4 or A equals to 12. Okay? Are we done?
No.
What do we need? What
Some
else is
A
missing?
both in the other thing.
So which equation do we need? The first one or the second one? Let's call this I'll call this asterisk and I'll call this double asterisk, which is more useful to us.
I think double wait. I think
Or should you
wait.
go for something even better?
Yeah, go for B equals yeah.
B, because I just don't even need all the others. Okay, so sometimes you must be strategic. Even though you got a square root, you don't be scared of the square root. You don't need to go in a hurry to make A the subject. Sometimes this is all you need. Yeah. Anyways, so you can, if you want, you can write down sub A equals 4 in asterisk. Okay, actually lazy. I'm just gonna say, I think this is quite clear. You're substituting the A in, so you can just say from asterisk. Okay, from asterisk. Wow, my asterisk looks very bad. Let me try again. Close enough. B equals to square root of A minus 3. So 4 minus 3. Or B equals to square root of A minus 3. In this case, A is 12, so 12 minus 3. 4 minus 3 is 1, square root 1 is 1, 12 minus 3 is 9, square root 9 is 3. Okay, so those are your answers. 4, 1, 12, 3. Okay. Any questions?
No.
Okay, good. Let's go to question 5. Over here, what happened? Let me see. You substitute in the point the 1/3, 6 into equation 1, then you get the first A and B equation. This is very good. Then you need to find the value of A and of B. So you definitely know you need to use simultaneous equations already. You need to find another equation involving A and B. Or you need to solve for A, solve for B. So what's the next step you did? You differentiate it. Then your procedure is correct, but it's just that there was a careless mistake with the working here. You could have went for quotient rule already, but you choose not to. You rewrite it as x minus b power -1, then you product rule. Then over here, there's a mistake you made. Up to this step is fine already. But when you combine into a single fraction, something went wrong. Can you tell me what's wrong?
When I combine into a single fraction, I know I do. I square the first one, which is not correct. I should times x minus b on the top and bottom.
Very good. Yes. Okay. Good. You understand already. Yeah. So let's just redo this part. Somewhere at the bottom where there's more space. Question 5. Let's go. Wait, what time is it? It's 10:10. Okay. Go. No time. I want to start new topic, but I don't think I have time. 2ax times x minus b minus away ax squared all over x minus b bracket power 2. Can you see how you can get this answer if you use quotient rule directly?
Yeah.
Correct, right? I'll leave it as an exercise for you to do on your own. I'm just going to continue. So here, expand, you end up with 2ax squared minus 2abx minus ax squared all over x minus b bracket square. So anything else we can simplify? Numerator?
Yeah. Ax squared. Take out the.
Take out the sorry.
Like,
how do you think about this? Yes. Correct. Sorry. You are scribbling away. Yes. Correct. Just ax squared. Just ax squared. Good. Okay. Then I think we can also factorize out ax, right? We end up with x minus 2b. Is that correct? Okay, now the denominator just copy and paste. Very good. So now that we get this expression, let's continue with the rest of the question. What did they tell us? The tangent to the curve at the point 1/3, 6 is horizontal. What does that mean?
Means that it is m equals 0.
M equals 0, okay. So
means dy dx equals 0.
After you see dy by dx, in this case you can sub in the x with something, right? What is that value?
Yeah. the
the x coordinate of the point where it is a tangent,
yeah,
which is
which is 1/3.
1/3. Okay, so maybe it's useful for you. I don't know. If you draw a sketch of the curve, just draw some scribbly line, like for example, just make sure you don't go too crazy like this, where you fail what's called the vertical line test. Don't draw dollar sign. This curve as an x-axis as your sketch of a curve. Okay. I don't want to talk more about vertical line test, but I'm just gonna say draw a sketch of a curve, and then for one of those points where they say the tangent line is horizontal, you just draw a sketch of the graph, maybe. Then draw a blue color tangent line that's horizontal. Then you label the coordinates of the point 1/3, 6, not drawn to scale. Okay. Right?
Yeah.
Then this will help to remind you, substitute x equal to 1/3. You will get the gradient of the tangent line, which is this guy. Since it's horizontal, so it's a 0. But wait, we already got the formula for dy by dx over there. We just need to sub in x equal 1/3. So what does it become? I write down the right hand side for you first, equal 0. Tell me the left hand side. Fraction. Let's start with the numerator. A
over 3.
A over 3, yes.
Then bracket open 1/3 minus 2b.
Good.
Then below is 1/3 minus b squared.
Very good. Bracket square. Can. Then how to continue?
A over 9 minus 2ab over 3. Equals 0.
Correct. Good. The denominator, you can just drop it. Can just cancel away. Ignore. Okay, because you can cross over this one, divide becomes a time. So 0 times anything will just give you a 0. So numerator equals to 0, essentially. Then now you have to solve for A and B. But this have both A and B. So you probably would want to get rid of the denominator. So how about if we multiply by 9 on both sides?
Yeah. A minus 6ab equals 0.
Correct. Yeah. 9 over 3 is 3 times 2 is 6. Yeah. 6ab equals 0. Good. Oh, we can factor out the A here. What do we get?
A equals 0.
Wait, factorize first.
1 minus 6b.
Okay, good. So A equals to 0 or 1 minus 6b equals to 0, right? So B equals to 1, 6. Okay, good. Are we done? Is that the end of the question?
No.
No, at the beginning, you already had one equation involving A and B, right?
Yeah.
Which is this guy, A equals 18 minus 54b.
Yeah.
So how do we use that? Do we need to use that?
Yeah.
Yes, because when we say or here, it's two separate cases. It's like this or that. Two alternate universe. Okay, there may be an overlap, but let's just assume there isn't. So let's deal with the case where A equals to 0 first. Then what's the corresponding B value? If A equals to 0, what's the corresponding B value? We have an equation relating A to B.
B will be 18 divided by 54.
Hold on a second. No. Let's make B the subject. Let's work it out. So maybe I can bring the 18 over. So A minus 18 equals to negative 54b. Right? So what's B equal to? Try again.
B equals to 18 divided by 54.
Oh, there's an A here.
But I thought the A is 0.
Oh, right. The A is 0. Sorry. Yes, you're correct. I wanted the general expression so that we can use it for Actually, do we need to? Okay, actually, we don't need to use it. But yes, yeah, correct. It's just negative 18 over negative 54, which is 18 over 54. You're right. Sorry. Wasn't following. Let me see. So what's the answer? It's 1/3, right? Okay, good. Then if B equals 1/6, then what's A? We got a formula over here, so we can just use it. So A equals to 18 minus 54 times 1/6.
9,
is
A equal 9.
Yeah, so this pair of answers or this pair of answers. 0 for A, B, 1/3 for B, 1/6 for B, 9 for A. These two separate answers. Okay, that is part 1. This is part 1 only. Let's move on to part 2. Okay, find the coordinates of the other point on the curve where the tangent to the curve is horizontal. What does that mean?
Yeah, it means that there's another point on the curve where the tangent. I mean, actually, I don't really understand. Like, I just know it means like there's another point, then the dy dx is also 0.
Correct, exactly. That's it. So what it means is the curve could be something like this, like a sine curve, or maybe, there's 2 points here. One of them is tangent, one of them is another tangent that is also horizontal. So which means that the m equal to 0, m equal to 0. Okay, something like that. But also I realized I made a mistake for part 1. Still incomplete. Let's read the question again. After they gave the equation, they said x not equal to b, a and b are constants with a not equal to 0. A not equal to 0. So this answer is, sorry, I forgot about the conditions. We have to reject since a is not equal to 0. Okay? Yeah, so we only got this as our answer. So since we already have a and b, we can just sub in into the original curve. So that means that y is now equal to, for part 2, we can just substitute in the a and b value. Y is now equal to 9x squared all divided by x minus b, which is 1/6. Okay, good. Okay, so how do we continue? Find the coordinates of the other point where the tangent to the curve is horizontal. So just need to find dy by dx. So how about we use quotient rule this time? Okay, let me just demonstrate it. Here's how I do it. Low d high, less high d low, draw the line and square below. I'll square below first. So then I do low d high. Low times d high. So differentiate it straight away. High is here. Differentiate, what do you get?
18x.
18x. Less high d low. So minus or plus? Minus or plus?
Minus.
Product rule is plus or minus?
Plus.
Plus. Quotient rule is minus. Okay, then you can think of it this way. Times and plus make things bigger. Divide and minus make things smaller. When I say quotient, I am referring to a fraction. Fraction is division. Then division you associate it with making things small, which is really just the same as minus. That's why you should have a minus. Does it make sense?
Yeah.
Okay, roughly. I'm just asking you to memorize it. Memorize it however you like, but just one possible way you could memorize it. Quotient, divide is minus. So that's why you have minus. As opposed to product rule. Product means times means you need a plus sign. Okay, low d high. This is low, this is d high. Less high d low. High is what? 9x squared. D low is what? Differentiate this guy, which gives you a 1. Okay, that's it. If you're faster, you don't need to put the d over dx of the expression now. But maybe you need more practice, then you just write it. But once you're faster, you can go ahead and write this down. But don't go and simplify this straight away in your head. 18x times x, 18x squared, and immediately write down 18x squared. Please do not do that. Please do not do that. I require you to show me the working. This one is the low, this one is the d high. Less, this one is the high, this one is the d low. Draw the line square below. Okay, at least at least shoulder's working. Okay, can then after that you multiply 18x squared minus 18 over 6 is 3x minus 9x squared over this guy x minus 1 over 6 bracket square. Okay, anything else to simplify? Yes, 18 minus 9 is 9. 9x squared minus 3x over x minus 1 over 6 square. Can factor out of 3x, you're left with 6x. That's not true. It's 3x minus 1. Or divide by x minus 1 over 6 bracket square. Can? Good. Okay, so what do we do now? Coordinates where the tangent to the curve is horizontal. Horizontal means gradient is 0. So that means you want to set dy by dx equal to 0. Which means you get this expression, equate it to 0. Then you solve for x, you get 3x times 3x minus 1 equals to 0. Is that clear so far?
Okay.
Can numerator becomes a 0. Horizontal, this is because horizontal tangent has gradient 0.
X equals 0. Sub x equals 0 into the thing above.
Why you don't want 1/3?
Because it's the one just now.
Ignore. It was from part 1. So we want to focus on this guy, then we sub in into y. So let's call this equation 1. Did I use 1 already? Haven't, okay, then I'll just use 1. Okay, so sub x equal to 0 into 1. Okay, and then we get y equals to 0. Yes, so that means you have a 0, 0.
Origin.
Yes, the origin. Okay, very good. Ken. And that's it for this question. Okay, then we are done with going through the questions. Now I'm gonna start new topic. Wow, very late. Okay, let me just go back to my differentiation notes. What's the date today? 221230. Okay, yeah. Application. Okay, I am going to send you a file. Give me a second. Not a file, sorry, a photo. Can you see? Exercise 12B. Okay, now we're going to talk about applications of differentiation. This is my short form for differentiation. In particular, we're going to talk about increasing, decreasing functions. I briefly mentioned it last week, but the key takeaway is that whenever you have an increasing function like this, okay, maybe I should draw a curve instead. Looks nicer. Whenever you have an increasing function like this, so imagine you have a rock that is rolling up. You're trying to push it up. There is an increase in its vertical height, right? As you move from left to right. Then this is what we call an increasing function. The key idea here is that for increasing functions, dy by dx is more than 0. And likewise for decreasing functions, they would be, dy by dx would be
more.
Instead of more than, it will be
less than 0.
Decreasing will be less than 0, right? The ball will be rolling down the hill as you go from left to right. Okay, this is the common idea. The height of the graph drops. Very good. So now this means that we can use it. And also the reason why is because the tangent lines are, if you can see the tangent lines I'm drawing here, 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 and here, they are all positive. They all have positive gradient. And the tangent line here, 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 and here, they all are negative gradients. Okay, so now that we know that, we can use it to solve questions. Let's take a look at the exercise 12B I just sent you on Telegram. It's from Xingli. Okay, let's try some of the questions. Let's take a look at question 1, part A. Find the set of values of x for which each of the following is an increasing function. So f of x is equal to what? X squared plus 10x plus 5. So come back to the fx notation, which we learned from remainder theorem and vector theorem. Need to get used to it. So instead of just the y equals and dy dx equals. So what we want to do is to first differentiate it. This entire topic, first step is always copy down the first original equation, y equals whatever, then you differentiate. But this is just an alternative notation, f of x, then f prime of x. Okay, differentiate, you get what? 2x plus 10. Very good. If you want increasing function, what was the condition? Your gradients are what?
Gradient is more than 0.
Very good. So that means f prime of x. Okay, right, here's how we present it. For increasing function, f prime x or dy by dx more than 0, which implies that, draw equal sign and then draw arrow like this. This implies that 2x plus 10, which we found previously, is more than 0. Solving this inequality, we get x more than negative 10 over 2, which is x more than negative 5. Okay, that's the answer. Easy?
What is this?
Sorry?
What is the thing before function?
Oh, sorry, increasing. Sorry. Increasing. Up arrow means increase. G with a line underneath is ing. My short form for ing.
Oh, okay.
Sorry. I write fast, so I always use short form. Sorry. Increasing. Yes, then this one will be. What is this?
Increasing. Decreasing.
Downwards arrow, decreasing. So obvious, right? Yes. No, it's not obvious at all. But okay, you'll get used to it after a while with my funny notation. Okay, moving on. So now we have one, don't want all very boring. You know how to solve all this already. 1B. How about if we try something like question 2, decreasing function? It's the same thing, it's just an inequality. Okay, let's try the hardest one. Let's 2F. Then you can have a recap of quadratic inequalities, the very first topic we went through. So let's do that.
Oh no. Okay.
Yeah, it's all coming back. To haunt you. So now, decreasing function, before you even deal with it, just differentiate. You get 3x squared plus 6x, 3 times 2 is 6, minus 24, and that's it, right?
Yeah.
Okay, so decreasing function. For decreasing, I'm just going to use the shortcut. For decreasing functions, f prime of x less than 0, which means that quadratic expression, this fella we found as f prime x, is less than 0. So now differentiation is over. Now it's back to your chapter 2 or chapter 1, the first chapter. How do you solve a quadratic inequality?
Factorize.
Before that, let's simplify as much as you can. Divide by 3 first. Then factorize. How to factorize? This one got x.
Calculator.
Plus 4 minus 2. Yes, calculator. Correct. Good. Then we end up with 2 roots, right? Which is negative 4 and positive 2. So this one, positive x squared, happy outside face. Positive is happy, right? Positive is happy. So happy face. Positive is happy. Happy face. Okay, then in this case, why do I draw this happy face? It's because when we say this guy less than 0, what we are referring to is the part of the graph that has negative y coordinates, which are these guys, right? Below the x-axis. Then the x-axis, here's negative 4, here's 2. So maybe the x-axis should be somewhere here. I mean the y-axis should be somewhere there. We're referring to the parts of the graph, the red color graph, where the y coordinates are negative, which is really just negative 4 less than x less than 2. You wrote the answer already. Okay, good. Then question 2, the rest will be homework practice. Let's move on to something more difficult. Let's try question 3. I'll give you more from the other text. Okay, question 3. A function is defined by the following. Y equals to x squared over 2x minus 3, where x has been defined to be more than 1/2. Okay, so don't look at values of x which are less than or equal to 1/2. Just focus on this values of x. Find the range of values of x for which this fellow here is an increasing function. So
differentiate.
Exactly. Yes, that's your first step. So I see a fraction, straight away quotient rule. So
low D high, less
low
high D low.
D high, less high, D low is what? 2. Draw the line square below. Done. Can? Following? Can? Okay, moving on. So now I can factor out 2x. Can you see I can factor out 2x straight away? 2x take out, I get 2x minus 3. 2x I take out, I'm left with just an x. But there's a minus in the front, so I bring it down. Over 2x minus 3 bracket square. Simplify a bit, we get 2x minus 3 minus x.
X minus 3.
Can we cancel off 2x with 2x, 3 with 3? No, please don't do this. You can only cancel off common factors. This is 2x minus 3 times 2x minus 3, the square there. Okay, Ken. What did they ask for? Increasing function, right? So save some space. I'm just going to write at the right side. For increasing function, this is also another lazy way of writing function. F then N underline. Okay? Can? Yeah. That's my short form. Can, good. So we want dy by dx to be more than 0, less than 0, equal 0. Which one?
More than 0.
More than 0. Very good. So this guy, copy and paste, is more than 0. Can you tell me something special about 2x minus 3 bracket square when x is more than 1/2?
Something
Let's try. If x equals to 1/2, 2x minus 3 is equal to?
If x is equal to 1/2, 2x minus 3 equals to 3 minus 3 equals to 0.
Equals to 0. Then if x is equals to 1/2 plus 0.1, then what's 2x minus 3?
It will become.
Okay. I don't know the answer.
Positive number.
Positive number. So 0.2, it will increase. It will increase. Then if you keep on increasing the x value, what do you think happens to your 2x minus 3 bracket square? It will also increase again, right? You just keep on increasing. How does the graph of 2x minus 3 look? Like this. Remember your graph sketching from secondary school?
Yeah.
Yes, from 1/2, it actually goes up all the way. Can you see it's increasing?
Yeah.
Okay, good. You can also prove that this guy is an increasing function. Correct or not? How to show it's an increasing function? Y equals to x minus 3 bracket square, differentiate more than 0. Same procedure, right? So bring down the old power, minus 1 to get the new. Chain rule, differentiate 2x minus 3, you get a 2. 2 is a 4, then 4 times 2x minus 3. You want increasing function. Lazy notation, more than 0. Because, this one, very, very bad notation. Let me just, because increasing, okay? This one, very lazy notation. Because increasing more than 0. So now we try to solve for x. So we get 2x minus 3 more than 0, x more than 3 over 2. Isn't that the same as what the question stated? X more than 1/2. So now confirm. Are you convinced that the right half of the graph is an increasing function?
Yeah.
Obviously, right? You don't even need differentiation. Just look at the graph. Okay. But more importantly, when it's strictly more than 1/2, what happens to the values of 2x minus 3 bracket square? It becomes positive. No, much simpler than that. It's positive. It's above the x-axis. So that means the denominator is really just a positive. You got question mark over positive is more than 0. What do you think is question mark? This one very, very beginning in your very first lesson in math. Negative over negative gives you?
Positive.
Positive over positive gives you?
Positive.
Those are the only two cases that will give you positive, right? Denominator here is positive. So what is the numerator? Can it be negative?
Positive.
Must be positive as well. Then we therefore conclude that. So the reason you should give here is, okay, this is all nonsense. It's not part of the working. Sorry, it's not nonsense. It's just an explanation of the concept you should know beforehand. You should just, all you need to do for presentation is to say that since or because 2x minus 3 bracket square is more than 0 when x is more than 1/2, this implies that the numerator is also positive because you can only have because positive over positive equals to positive. Okay, this is not official equal sign, but you get the idea, right? Positive over positive gives you positive. We know that this denominator must be positive. Then by deduction, this guy must be a positive on the numerator, which is what I've written over here. You don't need to write this reason, okay? This is not required. Just need to know at the back of your mind. Then from there, we get what kind of inequality? Linear, quadratic?
You get quadratic.
Quadratic inequality, which you have only learned in A-max, not in E-max. Okay? Only in A-max, which is what I've taught you. Okay, so here, same thing. You got 2 divided by 2. Then you end up with x times x minus 3 more than 0. Draw a curve because it's a positive x square. So happy face. What are 2 roots? 0 and positive 3. You want more than 0, above or below? Above. You must go and recap your quadratic inequality. So what's the answer?
So above. So x less than 0 or x more than 3.
Perfect. Very good. Can I must remember this idea, okay? Something square is always positive. It's a very common idea. They will always test you. That's why it's a yellow color question. A bit more difficult. Okay, let's try another one. Question 4. Profit function. Wow, profit. Finally getting into business math. If you really hate max, then you go to business. Unfortunately, you'll still need to know differentiation. Okay, let's take a look. So the profit function, P of X, of a manufacturing company producing X articles can be modeled by the following function. 2x cubed minus 21x squared plus 60x minus 5. Okay, so find the range of values of X for which the profit is decreasing. Wow, that's very bad. So when is the profit decreasing? First step you must always do?
Differentiate.
Differentiate, exactly, yes. So you differentiate 2 times 3, 6. Bring down the power and minus 1, right? So 3 minus 1 is 2. Continue the rest. Differentiate a constant, minus 5, you get 0. So differentiate 60x is just 60. The 1 bring down minus 1. 1 minus 1 is 0. X power 0 becomes a 1. Do you need me to show you the working, or is it okay if I go this fast?
No need. You can just do that.
Okay, good, can. Then what do we want next? Profit is?
Profit.
Read the question. Last sentence. Last word.
Decreasing. So for decreasing function, 6x squared minus 42x plus 60 less than 0.
Yes. So this guy less than 0. Then I think can divide by 6. So 6 times 7, 42. So this is minus 7x. 6 times 10, 60. So plus 10. Can we factorize this? Yes. X minus 5, x minus 2. Following so far?
Yes.
Can
For x equals to 2.
Wait. Sorry, it's an inequality, no equal sign.
Yeah, as in like the curve sketch thing.
2, 5.
Yeah, then below.
Below. Very good. Happy or sad face?
Sad face.
Why sad? No.
Wait,
You look at the
positive
code.
X.
You always look at
Positive X.
positive X. So look at happy face. Okay. Then below. Yes. So its final answer is
So it's X more than 2 less than 5.
wrong.
Wait. X less than 5 more than 2.
Write it in one line will be from small to big.
2 less than X less than 5.
Much better. Present it this way always, from small to big. Okay. It's a standard way. Okay. And question 5. Homework. It's the same thing. Okay, let's see. I have extra time. Very good. Okay, now I can introduce the next topic, which is the rate of change. Increasing, decreasing, very easy. I'll just move on to rate of change. Okay, so rate of change is a little bit more difficult. This requires prerequisite is number 1, mensuration. So you need to know all of your formulas of area and volume. Okay, you can prepare your own cheat sheet. Okay, I think I sent you the file before. Area and volume of all the different shapes, like a circle, equilateral triangle, an isosceles triangle, a square, a rectangle, a semicircle, a quarter circle, just divide by 2, divide by 4. What else? Parallelogram. What else? Trapezium. Anything else? Kite. It's really just 2 isosceles triangles. Okay. I missed something. I think I missed something. Rhombus. Yes, rhombus. Okay, a rhombus is just a special case of a parallelogram. It's the formula for the area is the same. Base times height for these for these 3 guys. Actually, for square, it's also base times height. It's just that the base and height happen to be the same length. For triangles, please remember there are those that are slanted like this. Half times base times height. You better know where's the height. Here's the base and there's the height. What is so special about the height is, with respect to the base, what angle?
Right angle.
Right angle. Perpendicular height. Okay, perpendicular here. So let me just label it red color. The height is outside of the triangle. Please remember there will be these cases. Anything else? Yes, you must also be clever in your manipulation of areas. So if you have a circle and then you have another circle inside, and then the shaded region is the ring here. How do you, and let's say I know the radius here is 2 cm, then the radius here is 10 cm. How do I find the area of the circle?
You just take big minus small.
Big minus small. Yes, total minus unshaded gives you the shaded, right? So pi r square minus pi r square. Do you remember this kind of questions? You've done in primary school. Hopefully you remember. You need to know all of them. Then for volume, you need to remember prisms, pyramids, prisms, pyramids, cones, and then sphere. That's it. Only 3 things. Basically, for prisms, right, you take every shape that you know, but you make it 3D. You understand what I'm saying?
Yeah.
Make it 3D. So like a circle, then you extend it a height. So now it becomes a Pringle. Circle becomes Pringle. Pringle can. All right. Then you just need to multiply by extra depth or height. But for pyramids and cones, this one, please remember, you need the base area, I'll call it BA, times the height. But you still need an extra 1/3 in front. Please remember the extra 1/3. For prisms, don't need. For sphere, no choice. Sorry. You need to go and memorize. 4/3 pi r cube. Sorry, 4/3 pi r cube.
Okay.
Volume of a sphere. Then for the exposed curved surface area, for this one is linking back to area already. Its curved surface area is 2 pi r square. 2 pi r square? Is it 2 pi r square or 4 pi r square? Sorry, let me just double check this. Curved surface area of a sphere. 4 pi r square. Sorry. Speaking of curved surface area, there's another one, which is for cones. It requires you to know this special formula, pi rl, where L is the slant height. Remember this? Yes, anything else? Oh yes, and you also need to know how to find nets. Like let's say you start off with let's say you start off with a cuboid like this. Can you see that if you open up the net now, you end up with something like let's say for example, like this.
Oh, shit.
Yeah, these kind of things. You need to know. Oh, sorry, wrong. Should be rectangle. Okay, because we are going to ask you for what's the total exposed surface area of the cone. And then we want you to maximize the area or minimize the area. All right. So before that, the tricky part is the finding out the formula, create your own formula for the total surface area. They're going to give you not just such a simple shape. They're going to give you, wow, this one got some special toy with a cuboid base. And then there's a cylinder, hemispherical surface like this. It looks like a bread. Looks like a bread. Okay. And find the total volume of this bread and minimize the volume or maximize the volume, that kind of thing.
Okay.
Okay. So mensuration is very important. That is actually going into applications already. But for rate of change, maybe sometimes the questions are simpler. So there's another trick. There's a trick that you need to know. That is linked to chain rule. You already know chain rule, but it's a different application. Different application. Okay, so without further ado, let's try some questions. Rate of change. Let me send you the questions. Give me a second. Sorry, can we have a short 2-minute break?
Yeah.
Can? Okay, I'll be back in 2 minutes. Okay. Mic test, mic test.
Hi.
Hello. I just sent you a file, AMX differentiation, Xingli rate of change. Please open the file and we will continue. Have you opened the file?
Yeah.
Okay, Ken, let me just write the title first. Sorry for the bad handwriting. AMX Xingli rate of change. So this is a PDF file I just basically took from the textbook. I sorted the questions into easy, medium, difficult. Okay, Ken, let's take a look. So for question 1, there's a child who blows air into a plastic spherical globe at a constant rate of 50 cm³ per second. Find the rate of change of the radius, the surface area of the globe, when its radius is 20 cm. So let's figure this out. What is the thing that is changing here? It is the volume, right? I hope you know the units for volume, cm³. Right, cm³. So when you see 50 cm³ per second, what it means is that you can write it as cm³ s power -1, or like from physics, 50 cm³ per second, like this. What this represents is really just the rate of change of the volume. Okay, if you remember, I mentioned at the very beginning of differentiation is that differentiation has two interpretations. It's either the gradient function, which is what we've been doing so far. Find the equation of the tangent, find the equation of the normal, and parallel to the x-axis, so gradient is 0. The second interpretation, which is what you need now, is the rate of change. It gives you the instantaneous rate of change, how fast something is changing at a particular point in time. Okay, and the example I gave you was the choo-choo train, the train that was like moving along a track. Okay, then we want to figure out, we had some distance graph, right? We want to figure out what is the speed or velocity at a specific point in time. Here, we're not talking about trains, we're talking about balloons or something spherical globe. Then a good notation to represent the volume would be the letter V. And since it is a spherical globe, we can use the standard formula for volume, which is 4/3 pi r³. Okay, where r is the radius. It is in cm. Okay. Now, some students may notice that the last sentence, it says when its radius is 20 cm. Oh, so does it mean I can immediately substitute in r equals to 20?
No. Differentiate.
Very good. Yes, you have finally understood the essence of the lesson, of all the lessons. Differentiate is your first step. If you substitute in straight away, what do you get? You get a number, okay? Then the question is, how in the world are you going to find the rate of change now? If it's a number, you try to differentiate, what happens? Differentiate a constant, you get?
0.
0. Then you don't need continue already. So if you try to substitute in first as your first step, then you differentiate, everything is wrong. Please remember that. This is a very common mistake. Wrong. How to continue? Impossible, right? You cannot continue if you get a constant. Then if that was the case, then all the questions are all easy already. Just substitute in, differentiate, get 0, then that's your answer, 0. Everything also 0. Cannot be, right? Cannot be. So please don't do this. Don't sub in first. Substituting is it's definitely not the first step. Your first step should be to differentiate. But here, we have a special trick. Whenever you see r over here, it means that r is a variable now. And from the context, it's also clear, right? As a child blows air into the balloon will grow in size. So the radius is always changing, correct? The breadth of the child is like 50 cm³ per second. So Can you visualize the balloon is growing in size?
Yeah.
Can so now that means that the radius is also no longer a constant, it is a variable. So instead of dv by dx or d whatever, it's dv by dr. It's no longer just dy by dx. It has to be d dependent variable over the independent variable. Are we clear? VAR is variable, and this R is independent variable. From your science lessons, you should know this.
Yeah.
Hopefully. Yeah, so dv by dr, what would it be? Leave the 4/3 alone. How about the pi? What's pi? 3.1415926. It's just a number. It's just a number. Leave it alone. Factor out. Then you focus on r cube. Differentiate r cube. What do you get?
2r.
3. No, bring down the whole power. R squared.
R2. Oh,
Correct or not?
Yeah.
Yes. So you just pretend that r is an x. If I gave you y equals to 4/3 pi x cube, I'm sure you know what to do, right? dy by dx.
Yeah.
Now we just change the letters only to fit the context. Volume and radius. It's not always y and x, but you get the idea. Okay. We just change the letters. So simplify and we end up with 3 and 3 cancel away. We are left with 4 pi r squared. That sounds very familiar. Right? What's 4 pi r squared?
4 pi r squared.
Have you seen this formula before? Yes.
I mean, area of circle, but times 4.
Yes, correct. But more importantly, it's also the curved surface area of a sphere. Maybe I should write this down.
Oh, lol.
Oh. What a coincidence. Or is it?
No.
It's not a coincidence. But I'll leave that for another day. Why is it related? There is a reason. I'm not going to talk about it yet. So dv by dr happens to be a 4 pi r squared. Just accept that for now. But what is the question asking? The question is actually asking you for what is the rate of change of the radius. What does that mean? Rate of change of the radius. That is really asking you to find dr by dt, where t stands for time. In what units? Seconds. How do I know it's seconds?
How?
Because the question mentioned 50 cm cube per second. You follow the question's units. The moment they mention seconds, you follow seconds. Whenever they ask for rate of change without saying with respect to something, it means with respect to time. This is read as rate of change. It's no longer just dr by dt. It's rate of change of radius with respect to time. This phrasing with respect to time will not be mentioned. If it is not mentioned, by default, you're supposed to know that it is referring to time. So the denominator sort of the denominator in this fraction is going to be a t. Okay? Can? Clear so far?
Yep.
It's a convention. It's a convention in math questions. You have to put down time. Then after that, we need to realize that there is something that I didn't explain thoroughly, which is the theoretical way to describe chain rule. But I'm just going to introduce it now for the, in a way that is useful for this question. Chain rule can be interpreted as if it was a bunch of fractions being multiplied together. Not accurate, but useful and practical for solving this kind of questions. Let's take a look. dr by dt, do you agree that you can always split up a fraction like this? Happy face like this. Happy face will cancel away. If it was a fraction, technically, dr by dt is not a fraction. Okay, it is not a fraction. A dr by dt is actually a limit. And a limit has a definition that is very crazy. Let me just write it down for you. If you want to say the limit of a function as x approaches a, what equals to some L. This is equivalent to saying the following. Are you ready? Can for epsilon more than 0, there exists a delta more than 0, such that for x an element of the domain of the function, if you have 0 less than modulus x minus a less than delta, then modulus fx minus L will be less than epsilon. What did I just say? This one don't copy. This is not in Amax. It is not in H2 Max. It's University Max. Okay. This is the idea of our limit, the epsilon and delta idea. If you're interested, you can go and read more about it. I can send you a comic book that explains more about it. If you're interested, you can go and read. Comic book, very fun. I read it when I was in secondary school. You can go and look more about it if you're interested, but you don't need this. Okay. It's not a fraction. It is not a fraction. It is way more complicated. I mean, after a while, it actually gets quite understandable. It's quite a standard idea. But for the purposes of Amax, you need to know this trick, which coincidentally makes a derivative behave like a fraction. So you can split up the dr at the top and the bottom, and then you introduce a happy face like this. But of course, we're not gonna put happy face. This is how we're gonna put bracket around it. Instead, we're gonna put down something that's more relevant, which is a variable that we already know. Can you see one variable that we have already used here that that is useful to us? Oh, right, I forgot to mention 50 cm cube per second is a useful information. This is a constant rate. And it can be represented by a fraction, which is d something over d something. Here, cm cube per second, right? Means the volume per second, right? So wouldn't this just be dv by dt? Can you see that?
Yeah.
Okay. So now take a look at this happy face. What do you think you want to put in the happy face with? Replace the happy face with something that you already know. dv by dt, right? What do you see here at the bottom? dt, right? So what do you think you want at the top? dt at the bottom, dt at the bottom.
dt, dv.
dv at the top, exactly. So you introduce a dv. Because we already know this, that's why we can put a dv at the top. So if you have dv at the top, no choice. So at the bottom here, you want it to disappear. What should be placed below dr now?
dv.
Exactly, dv. So that means that just one line. Don't need write so much. Your first line should just be dr by dt is what the question asks for. Find the rate of change of part 1, the radius. So dr by dt. Then you split up, do the trick of splitting it up like this. Then you look around, look left, look right, look up, look down until you finally realize, oh, it should be a dv. It's a dv. Why is that useful? Because dv by dt here, do we know the value of dv by dt? Yes, right over here. 50. Then it just becomes a times 50. But what about dr by dv? Don't know, right? We don't know what is dr by dv, or do we? Just treat it like a fraction. So isn't this the same as 1 over dv by dr? Yes, right? Like 2 over 3 is the same as 1 over 3 over 2. Can you see? Reciprocal. Yeah. What's dv by dr? What's dv by dr?
dv by dr is 4 pi r squared.
Very good, exactly. So we can just substitute in 1 over 4 pi r squared times 50. You can go from here to here directly if you want to. I usually don't write this. Okay, so I'll just put a pair of brackets around it. Yeah, just identify that dr by dv and dv by dr are reciprocal relationship, 1 over. So just flip it around. Okay, are we done? No. Why? Because this question is actually read in the following way. Find the rate of change of, are you looking at the question?
Yeah.
PDF. Okay, look at the question. Don't look at my screen anymore. I'm just looking at the question. Here's how you read it. Blah, 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 at a constant rate of 50 cm³ per second. Find the rate of change of part 1, the radius, when its radius is 20 cm. That's part 1. Then for part 2, you're asking blah, 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 constant rate of 50 cm³ per second. Find the rate of change of the surface area of the globe when its radius is 20 cm. So this last line, when its radius is 20 cm, is used 2 times, okay? Are we clear?
Yeah.
Okay, now, very good. So now, but the radius is 20 cm means r equals to? R equals to 20. So what do you think you want to do now when you see a r here?
Sub in.
Exactly. So but sub in with r equal 20, this notation, what's a funny notation we introduced?
Funny notation.
When you want to substitute in, do you have to write down sub r equals 20? Don't need, a more efficient way. Exactly. Draw a vertical line, r equals to 20. Then equals to, copy and paste the formula, but you replace the r with 20. And then you're done. But let's learn to give your answer in exact form. So let's work it out. So pi cannot do anything to it, leave it alone. 4 times 20 square is, let me use a calculator. 4 times 20 square, I get 1,600. Okay, pi times 1,600 is not a standard way to write it. So instead, write it as 1600 pi. Good, very good. Now the 50 is multiplied, right? So you can go to the numerator. We end up with 50 over 1,600 pi. Are we done? No, must simplest form. So 50 over 1600, use a calculator, you get 1 over 32 pi. But please take note, if you write the pi like this, it's wrong. If you write the pi at the top, it's definitely wrong. It has to be at the bottom, so 32 pi like this.
Okay.
What's the units? This one is a physics question already. It will be engineering, you'll see this again very, very often, rate of change. R by T, what's the units for R? Radius.
cm.
Yeah, what's the units for time?
In this case,
the child is blowing at a rate of 50 cm³ per.
A second square, is it?
No, square. Wow, that one like what velocity acceleration already? No. Too fast. No. Seconds, just seconds. Time is second. Correct, no, you measure time in seconds. No square. Okay. Sorry. Right? Why got square? I don't know. Time just seconds.
Change of rate.
Because of rate? No, don't have. Not so complicated. Okay. Time is just seconds. Okay. So you see R over T means cm per second. So units is cm per second. You must include units, if not you won't get the full marks. Okay. Ken, that's the answer. Easy. That's the easiest question already. Ken?
Okay.
Part 1, not done yet. Still got part 2. Let us move on. Part 2.
Curved surface area of the globe. The surface area.
So can you see the procedure already? Let me just summarize what we've done so far. First step is, maybe I use a different color. I'll use, I don't know, pink color. Okay. First step is you identify, volume. Because you have a sphere, right? And they say cm³ per second. So you think of volume. So you write down the formula. Then the second step is differentiate. Okay, your first step should actually be to write the formula. Second step then is differentiate. Okay, with respect to radius. Are we done? No. Then the next step is, maybe this should be a third step. I should have done it as a third step. Is to identify what is a constant given, what is the constant rate and what's given. They gave us dV by dt as a free gift. Okay. Constant rate of 50 cm³ per second, so volume per time. Volume per unit time, cm³ per second. Then your fourth step is to read the question and write down what they want. What is it? They want the rate of change of the radius, which is dr by dt by default. Okay? Then dr by dt standard trick is to split it. So maybe I'll call this the, okay. Would you want to split this up as a fifth step, or do you want to call this 4 part 1, 4 part 2?
Anything.
I think I'll call it as a separate step, split. And then it's a bit too complicated. I do it in one line. I'll call this 4 part 1. I'll call this 4 part 2. Split. You split. But you have to be clever in the splitting. It's a bit complicated. Some students are struggling with this. You must first identify what you need. Question tell you radius per with respect to time by default. So it's R over T. Then you split it. R at the top left, T at the bottom right. Then you introduce the V. Why V? Why did you choose V? Because there was a V at the beginning in step 3. And this was given, dV by dt. So it will be very convenient to have a dV by dt here. But how come the bottom also needs to be dV? So that we can pretend they are fractions, cancel away. And we end up back with dr by dt. Of course, a thing to note is that it is actually not a fraction. Only in university, then you need to care about this. For now, don't care. Just pretend it's a fraction. Can?
Okay.
Let me just write this down. Pretend it's a fraction. And this is actually chain rule already. You take the outer function with a differentiate. You differentiate the y with respect to the inner. With respect to the outer function. And then after that, you take the. Actually, let me think carefully if I'm saying this correctly. Yeah, correct. You take the r, you differentiate with respect to the outer function. Then you take the outer function, you differentiate with respect to the inner function variable. Is that useful? I don't think it's useful. Just remember this trick, okay? Just remember the trick. Given, then that's why you want to have dv at the top. You must choose the happy face. Maybe I should mention this. This is quite important. Choose your happy face. In this case, the happy face being dv, okay? And the reason is, I already mentioned many times, is because of step 3. Okay, step 4 is now done after you split it up. Then that's when you need to start to substitute in the correct values. For dv by dt, it is clear. We are given that from step 3. Step 3, right? Whatever was given. Then given. So you just put in here. Then how do you get the dr by dv? How do I get the 1 over 4 pi r squared? Can you tell me?
You change dv over dr to the bottom. Then you sub in 4 pi r squared.
Where do you get 4 pi r squared from?
You get it from step 2.
I got it from step 2, from differentiating. Very good. Okay, so this is a common trick. So this is probably, I will call this, what do I call this? Reciprocal. Take the reciprocal, then sub with step 2. Maybe I'll just call this entire step as one step. Step 5, sub with appropriate or apt expressions. Just sub the correct expressions. Yeah, so dv by dt, which was given. dr by dv is not given. You need to do a bit of algebra. Rewrite it as 1 over dv by dr. Then you substitute with what you found, which is 4 pi r squared. So 1 over 4 pi r squared. Are we done? No, you still need to do the last step, which is substitute the r with
Substitute the r with 20.
Which was also given. R value was given. Can? Okay, let me take a, how do I, wait. Now I want you to try Let me send you the file first. Give me a second. This guy sent. Okay, 6 steps. Now let's try part 2. Let's try part 2. Tell me what to do. Have you received the PDF?
Yeah.
I will update the file again. This one is just one of the page for today. So let's try part 2. Okay.
Okay.
So find the rate of change of the surface area of the globe when its radius is 20 cm.
Okay.
Volume of a sphere is 4/3 pi r cubed.
Okay.
Total curved surface area is 4 pi r square.
4 pi r square.
These are facts you should already know. Let me just share screen first. Sorry. Let me share screen first. I forgot to share back the screen.
SA equals to 4 pi r square.
This one strongly advise you against using 2 letters. No, use a single letter to represent a variable. Do not use 2 letters. That's super confusing. Always use a single letter.
Then
Okay, this is important. Always use single letter. Use A lah. Just use A.
Okay, A equals to 4 pi r square.
Good.
Then differentiate 4 pi r square.
So sorry, tell me what is it? D what by D what?
D
It's not V anymore. Now it's what's on the left side? The left V
A dA over D.
D pi. Do you D pi?
dr
R, the variable. Yes. Equals
dA over dr equals to differentiate 4 pi r square.
Carry on.
So 4 pi just stay the same. Then to 8 pi r.
Make sure you got a bracket and 8 pi r. Yes.
And then you can split
Split from what? What was the beginning you split? Do you take this and you split it? Take this and you split it? Is that how you do it? What should you identify first? Okay, maybe I didn't write this down. My step 2, I should have said. Read the question. Read the. Oh, sorry. It's 4 part 1. 4 part 1. Read the question. Read the question's requirement. Here, the question in part 1, they required the rate of change of the radius. But here in part 2, they ask for rate of change of the surface area, right? Rate of change of the surface area? Yes? So what is the rate of change of the surface area? D what over D what? Is it dA over dr?
dA over dt.
Much better, exactly. What's given? What's given? Step 3. It was just the d. What's that? dV by dt 50 cm cube per second. Okay, that's given. Then dA by dt. Then what we were saying, split, right? How to split? First fraction, second fraction.
You have dA over dr. So on the right. Yeah, okay.
How? Second fraction?
The other one is dr over dt, or 1 over.
But dr over dt is the same as 1 over?
1 over dt over dr.
dt over dr. Okay.
which you have also.
Do you need to reciprocal here? Look carefully at what you have. What do we have here?
dr over dt. Which
dr over dt. So dr over dt. Need to flip on.
no need reciprocal.
So this one is not necessary. Sometimes the skip steps can skip one. You must be flexible. Okay, so dr by dt. Maybe it's better if we clean up this fellow here. Before substituting the r, we obtain a dr by dt expression, which can be simplified as 50 over 4, which is, let me calculate this. 25 over 2, so 25 on top, 2 pi r squared at the bottom. Okay, this is dr by dt. Okay, we need to use this. Let's just call this I'll call this star. Okay, then from here you can sub star. All right, which will give us 25 over 2 pi r squared. Are we done? No, still got dA by dr. What's dA by dr?
8 pi r.
Correct. So this one is substituting the appropriate expressions, apt expressions. Good. Then let's just clean up a bit before we continue. So I see 8 and 2 cancel away. This becomes 4 here, 1 here. Pi r over pi r squared. So this becomes 4 times 25, 100. Pi r over pi r squared. Anything else to cancel?
Pi.
Pi cancels away. Anything else?
And then the r.
R, very good. So finally we are left with 100 over r.
So
okay.
5.
Very good, because r equals to 20. Yes. So the last line is dA by dt. Sub in r equals 20. Then we get 100 over 20, which is 5 units.
cm per second.
Very good. Then that's your final answer. Easy?
No.
Good answer. Okay, it is not easy at the beginning. Also, one more thing to take note is that the sign matters. The sign matters. So what is sign? Plus or minus sign. Okay, plus or minus sign. Not the cosine sign. No. Just plus minus. So it's positive 5. What does it mean? Positive means it's increasing. Positive, you remember, I just went through positive rate, positive derivative means increasing function. In other words, area is an increasing function with respect to time. In other words, if you draw a graph where the x-axis is time, y-axis is area, the graph is increasing. Okay, at least at a constant rate when r equals to 20. Okay, so when r equals to 20, there will be a certain way that the function behaves, the area with respect to time. Then it will be 5 cm per second. It will be 5 cm per second. Okay? Something like that. Okay. Maybe the x-axis is more like a rate. It's more like r. I think it makes more sense if it's r. So it means that when r is 20 here, there's a certain area. Then you can draw a tangent line here. Okay, the tangent is not with respect to r anymore, it's with respect to t. So this one is multivariable calculus already. I don't want to talk too much about it. I'll just stick to a t here. And then at a particular point in the graph, there is a rate of change that is 5 cm per second. So whenever you see a positive sign, the main idea here is that the area will be increasing. Okay, and it makes sense, right? Logically. Look at the context. If a child blows air into a plastic spherical globe, balloon, it will increase in size. Okay. Take note that over here, right, we wrote down dV by dt equals to 50 cm cubed per second. The sign matters. The question will be tricky. Here they say constant rate of 50 cm cubed per second. you are supposed to understand from the context that the size of the balloon is increasing. So the volume is increasing with respect to time. So it has to be a positive 50 cm cube per second. 50 cm cube volume per second. Right? Has to be a positive sign. The question may change into a different case, like for example, there is a upside down cone like this, and there is water inside it. Okay, there's water inside it. Water is then dripping out from a small gap in the bottom of the cone at a constant rate of 2 cm cube per second. Then in that case, your dV by
minus
dt
2
will be negative 2 cm cube per second. Exactly, yes. So the context matters. Physics a bit. Okay, but it's not too complicated.
Vector.
Sorry?
Vector.
Vector, yeah, correct. Yes, similar to vectors. The sign matters. Okay, the sign matters. So yeah, it's very late already. My homework for you, I will assign later. Can?
Yeah, okay.
It will be all for today. Free of change, the introduction. I'll send you the file later. That's all.
Okay.
Thank you.
Thank you.
Bye-bye.
Bye.